All right, so here's my video, Champlain Tower South sagging rectangle array, because removal of BMA equals deflection. Removal of BMA, I just don't mean that. I mean that they didn't reposition also, rather. I mean they did not reposition the supports for the deck. It appears they did not reposition the supports for the deck, which gives us this column that's right about out here, which changes, which I often say triangle array. That's the way my brain is thinking, but it's rectangular array per ACI. If you want to think about it, if you want to track it down and try to debunk me, look under rectangular array and prove me wrong that it was not, that it was out of bounds. And I will do a video showing how you prove me wrong. All right, the rectangular array, it's out of bounds, and now we have, this is a clip, a thumbnail I took out of from Josh's video doing a comment to him, a comment reply, a counter to his video, and he stated that the engineer that showed up there was a female. I believe he stated that, and also that she stated, that's why I'm going to say she, that's why the significance of that she stated that this was the roots displacing this. I think he was on target with that, pushing back here. But we see that the elastomeric type paint can stretch. It's stretchy, so it can hide some cracks if it did. But that's not where I'm going. All right, don't bother pausing and looking for that. Already, it's nothing there. So now let's look at this image I have, and let's go tight over here. And I'm going to play a little Columbo on you. So I figure you're going to stop the video and do some looks and whatever you're going to do. I'm purposely shortening this up. I do have a larger image of it. Looking at this gate, it's not deformed. All right, it's not deformed. Talking to Professor Lehman here, so if the butterfly happened just on one side only, that is from the wall first, you would see the one side only, the gate deformed. The hinges at least broken off the hinges or deformed. These gates present as being swingable, operable. Now let's look at the top railing. I left a hint to this to many other views. Okay, look at the pickets, as you guys would call them, balusters. This railing here, right? And we look at, okay, so no breaks. They look about uniform spacing. Don't worry about the stuff here. I'm not doing any secret thing on you that yet. So, okay, still uniform. Looks like a joint there. Railing, little different than that one. Okay. Oh, okay, here's a bend. Here's a change of direction. The problem is this change of direction could have been created by this material here landing on the deck. It could have been straight. Now let's deflect over to Cassandra Bilodeau Stratton. As we understand it, she contacted her husband and said there's a sinkhole out there by the pool. So when you're trying to figure out, and her view is blocked, pretty much obstructed, her view would be above this area here. And be mindful, guys. Her mother and I spoke, and she watches the channel, so be mindful of anything you might say about her, please. All right, so the mother did not want me to call her the model chick. I was trying to be respectful in that, respecting that, she worked hard for that body. I saw a couple of images. She was nailing it. I mean, that was rock hard. If anybody could physically maneuver fast, it would have been her. And so that's another story, I guess. But she was getting data from her husband at the time. Don't want to make him feel guilty, but hindsight, of course, he would have told her to leave immediately. Anyone would have rather. So her view is here, obstructed by these overhangs. It's up further. She's up about one more story above here. I don't want to show the room right yet. I mean, show that, but because of the mother's watching. I know, Mom, you wanted to me give you more details on this. No, I don't think you want those details. All right, so the of what you wanted. No, I can't do that. It serves no. It's not good for you. So the Cassandra Ability Stratton was able to observe from there what she said is a sinkhole, which is this direction towards the pool. She's not able to see underneath of the car area, but she sees further out. So this tells you that your failure was identified by a witness, Cassandra Ability Stratton, who called her husband and stated such that the pool looks like it's a sinkhole out there, the pool area, the pool deck. So that tells you it's there. She didn't say it's all the way over to the building. So the stages are such that I would argue that it's some, if we have more imagery here, that see this fracture here? Remember I showed a video with the fracture at the top of the deck. I hope to link it below or you guys can request it. The fracture there. That fracture there aligns roughly with the fracture here. And this would give us our plane or deflection. Okay, looking at this railing, now I am playing Columbo and I'll give you a hint down here. Looking at this railing first, we see it's hinged and it's rotated towards us. The railing was not at this is a glass shutter. It was not there. So it's turned in. But we have a problem here. We're missing a couple of sections of pickets right here. And would you say that this material came down, impacted this, and broke it? Well, it's not twist. It's not turned. It's not torqued. It's straight. These appear to be roughly 90 degrees, let's say. And then they're ripped. This is manufactured, welded, not on the field. And it's ripped away and probably powder coated. And you're looking at the exposure of the metal there, where the powder coating did not take. I'm going down the line of powder coating. This is where it's embedded in the concrete here and here, and I mean the concrete caps probably, the railing. And then there's a planter box. I think this is not just about even with the planter box. That detail. So the fracture is here. This is the one that we can see that, right here. Remember, point here, but look here now. See this fracture in this planter box? This would be coming from the deck, not an impact from the top. Or we have a deflection in this end impacting, and it fractures, and this is holding on rigidly. But nevertheless, we have a rotation left, or we have a rotation right here, putting the fracture down here at the deck, and we're going up. Oh, but look at the gap down here. So we have a twist, a rotation, an impact, probably down here from this material. Let's account for it. Rotating this entire planter box from this end, grabbing your hand, rotating, rotate this towards the structure. And now you'll get this coming out the bottom. You'll get this rotating in there to some degree where it impacts the counter wall. And then this counter wall. So then the fracture identifies itself here. And this material impacted, I don't see it removing the paint. So we don't see any scuff marks that it slid down and removed material. So the impact of this, not from this wall, I've got to find it from different directions, either from the floor or an impact of materials. So using impact of materials, we get a rotation and we get a fracture here. There's the planter box still in place, and I believe, and I'm going to say in fact, Liberty, because I need to find the other image. The flooring system goes over to this doorway over here. So there's some impact here that caused the rotation of the deck that gives you a rotation here. Counter wall here, remember? Counter wall, little mini wall? There's a counter mini wall there. So there should be a fracture right about here where this is a middle section that took a dive in. All right, I have to resolve all these cracks, everything I can see, observe. So then again, we have the floor cracked here. This is identified here. As we look at this, we don't quite see rebar, this direction. I don't see rebar coming out of here. This appears to be a column. And that might be one of the, coloration's got me. But nevertheless, here's our fracture line here. And this looks like this was, part of that wall system. I have something else to show you. I just want you to build this material up for you. So this is where the wall and the cars fracture away from. All right. It's like they took an elevator ride down, flat down. Right. This is a panoramic. So you'll see some stitching issues here. See how it's not stitched? But it's very slight. And a light deviation there. And you can probably extrapolate back a little bit further into here, but very light. So some of your deviations are in this plane. So the panoramic looks like it's stitched. And so it'll be here, and the next one will be over there. The next one will be here probably. So we have the fracture. Remember this fracture right here, this mini fracture is similar to the fracture at the south wall. It's on top of a fully supported wall system, if you will, a column. And let's move away from this now. We'll come back to that in another one. I'll review more. I'll let that talk some more in another one. Going back to your cars again. Again, the butterfly, I believe, is right down the middle. I mean, it's literally looking at you in the face. This one goes down. This one goes down towards that direction. Our planter box is not fractured here. It's not fractured below the planter box at this line here. So I am not stating that the crack is in the floor here. It would dissect behind the cars anyway. We'd see it more closely there. But we see it. Literally, we see it there. The problem is people are getting too sucked into this back wall. This is where the narrative is going. This wall here. But if you look at the reinforcement, which a lot of people believe is not present, it clearly is bent over. To bend this over, there was some engagement in this floor. It was being held by this rebar, this vertical up and down. And it held to some degree before it also broke free. And then you see this section here, which people are saying no rebar. Well, it's a photograph. It's imagery. Photographs, depending on how they did it, how they blew it up, can show that it looks like there's no rebar present when there really is. I mean, look, this is concrete we're looking at, and yet we don't know concrete to look like this. But in this photography, this camera, concrete looks like that. These marks here were not somebody going around with their hands scratching this down. This is the reinforcement I spoke of. This reinforcement is where you see it. It's across the top here. This is the slab reinforcement sliding down the wall. This is it. These are its claw marks, its indicators. There's a piece of rebar bent over, and it didn't bend over just because it wanted to. It was being pulled over by the slab engagement. That's probably a piece of slab. Maybe the way it. Well, I don't want to say that, but I'm going to say it's a piece of slab rebar. If I bend this back up, I'm too far above the floor as I visually bend it back up. Same thing with all this. This is all rebar that's been bent down. So when she observes the butterfly, the sinkhole, she sees that what appears as a sinkhole, but not here. She can't see this. It's behind the cars. She's looking to the left, and she thinks a sinkhole is taking place. Now, like Professor Lehman states that she believes it started at this wall here. I believe that's her belief. But these are all perfectly lined up, if you will. They're not disturbed. They're just loosely placed, as you can see. So if this was to go down first, these would at least flap up, flip onto the deck, etc. But it doesn't do that. This is where some reversal took place. This is how loose they are. There's a little bit of waterproofing there that they added. This is going to be above here, this connection here. This is where it had a little more engagement with the steel, the deck, and that's the tile that they butted there. It could be a little bit of tile. I mean, 1 inch. We don't know exactly how much tile is there. Now, here's supporting data of what I just said. Looks like a little sliver. All right, so there's that engagement. But if you scroll down the rest of this wall, again, you see that this tile is, that looks like maybe a grout, but the tile is still perfectly okay. It did not start, and I'm 98% into this with my investment in this, that it did not start the wall. That's did not happen. All right, let's go back to a huge give me for you. So remember, we have the video. I mean, Josh's video and the his his position. And it's interesting. You see me trying to debunk, but just trying to give a counter position from Josh. Not quite debunk him. Well, besides that one with the post tension, I'm not trying to debunk him at that point. I mean, from there, I'm just trying to give him a counter position, a counter thought. He does have a voice, so trying to see if he'd open his voice up to seeing, oh shit. But instead of doing that, he deletes his content instead of going, I remember when I made that mistake. No, that's all deleted. That mistake doesn't exist anymore. And so can he accept a counterpoint? Apparently not. He just deletes his position, and then it never existed. He never had that original point. Going to the roots. You can see literally the roots down here, the structure of the tree, of the bush. And we see looks like 12-inch block, hollow core. We don't see roots flying across here, across this position. You see that there's part of the base of this planter box. It's kind of unique. This is the slab. It looks like the slab detail, right? The structural slab. Hold on. Well, they had a slab added on top, if you recall. So the question I ask, is this the structural slab, no reinforcement presented? You think you would see some diagonal reinforcement or cross reinforcement at this point. So then I'd say, okay, well, considering it didn't just skip rebar right there, and I don't see any indication of popped rebar. So the spalling, what I show you guys that in the other videos. And this looks like the edge, the top of the deck. So I go, okay, this is the structural slab. And this is probably in line with the block wall. So I'm probably looking at a coating, and this is block wall similar to here, even though it looks smooth. Present smooth. Remember photography and etc. This would have been a little bit rough, even if it's a end block. It would have still been present a little rougher than that if you're looking at it closely. So over here we see our butterfly, my biased butterfly. So here's that. My downward force is here. Oh, butterfly, for, I guess, professional lumens new to my butterfly roofs, 1950s, right? 1960s. They had the roofs come in like this, and the gutter was in the middle. They called them butterfly roofs back then. And so I called it, this reminded me instantly when I saw it, I said, looks like a butterfly roof. And it's punching shear, so I coined butterfly deck punching shear, butterfly deck failure, punching, where they both go at the same time, the left and the right. As we look at this for direction, Professor Lehman, we can see that these numbers are scratched off. All right, they were not scratched off in the basement with the walkthroughs. This is scratched off because, as I believe Cassandra Bilodeau Stratton, Cassandra, damn it, Cassandra. I apologize for getting it, for messing up. Ms. Stratton, you can see that her part of her visual would have been probably here, seeing that the butterfly failure pulled down first. And, well, as it's pulling down, that some torque action as it's going down is pulling back towards here. More dragging's going on. So on the opposing side, we probably wouldn't see much besides this running down there, fracture there. This reinforcement rebar tells us that this rebar right here was across the head, further down here. It lost engagement. It lost its bond strength. I know that side lost because this side is still engaged. So this is the side that had so much deflection, so much load. Well, look, a planter box, cars, etc. So much stress on it. The recycling of these cars. I call this a bridge deck, as you guys may or may not know now. Anybody knew that this whole structure was simply a bridge deck because cars drove on it and they parked on this bridge. It's above it's a bridge. Cars drove around this bridge, parked here. I believe that so this not to happen in the future, all bridge decks, including these parking decks, which are bridges, they transport cars and people, and then they act as a parking garage, need to be inspected every 2 years. They also need to be isolated from the structure so they can free fall on their own, considering for redundancy. So the inspection, gets swept under the rug, gets whatever pushed down the road by a few weeks of repairs, and you get a total collapse. So I believe that to save this, you need to isolate all your structures from your bridges. Stop connecting your bridges to your main structure. This is what I think of this. This is where the BMA was to be connected here, never to happen. This is the one that's part of the rectangular array, not triangle as I state, rectangular array that's too far off. This one and these are positioned too far from each other. So from here, this one should have been approximately here, 6 feet in. This one located, but the BMA was to transfer the load from this parking area, and it was going to be a step down into the pool deck area. That was removed when they changed the elevation of the pool deck up 1 feet to equal the same elevation as the parking deck. When they did that, they removed the BMA, saving what I call Cadillac money back then. They probably could buy a Cadillac or a few of them when they changed it there. They also changed the drop slab detail at the slab drop detail at the main structure from 2'6" down to 1'6". That's more Cadillac money, buying Cadillacs. And let's get away from that. So we see that the scratching is off here. So there's your butterfly, your loading. Now I have one more for you, a major one, if you will. If you look at the very top of this, we can see that this is approximately 2 weeks. I think Josh said 13 days, 2 weeks, something approximately before the collapse. This imagery, we see it's fully fractured here. Okay, there's the top of the wall going down. And that's this wall system here, and there would be the corner above this, past this column, over to here. That's the corner. So that corner goes there, and that column is back here somewhere. And this is the column here as it punches through. It's not punching through anything. The deck is punching around it. All right. Now, this is the Columbo move. I'm waiting for it for you guys. You can pause the video if you like to try to figure it out before I state it. I'll give you more hints, and you can pause at any time. This is the cap. Let me give you a little more. That's the corner. You can see the paint detail that they painted around to the waterproofing wrapping on this corner here. You can pause any time and start cycling through your brain. What do you make of it? All right, let's just look at it. So this building collapsed. Next, the main structure collapsed after the pool deck. There's that fracture. The detail I mentioned goes over to. This fracture goes over to. Okay, the corner of the okay, L. This is K, L over there by the planter boxes. This fracture here. It is elevated on this side. Remember, vehicles could be down there. It presents as flat. So, Professor Lehman, we talked about the planter boxes in the back being flat. And this presents as flat. These present flat. I'm not saying they're not on a slope. Excuse me. I'm saying there's no crown here. See, it's pretty flat. If you look at this also presents flat. There's a little bit of high side here now. It looks like, if you continue, this is the high side. But it presents flat. So this gives us a profile of the deck. There's a little bit of fracture. There's a significant fracture here. Elevation change, right? As something's under there, maybe a car is there, and this gives us a crowning. Again, look at this here. This is the planter box. It was up here. There's the other part of the black planter box. There's the shrubbery. The planter box is inbound inside of this K column. Just makes it inside of it. No scratch marks. No scratch marks on this one. Very significant. This one's removed. Our steel heads, right? Our shear head. This is the engagement to lock the deck in. Your critical shear zone area. The steel here, ×4. Sorry about that. I had to clear my throat. Didn't want you guys to hear me clear my throat, did you? So this has more to say. This was up here. When this went down, it was ejected off, right? So this side, when it's going down, and there is a crown, a change direction moment here. This right here is our change direction. You can see it here also. But it's going down because it just can't hold on one side. So it does go down with it. At one point, this pulls down first, then it goes down with it. It didn't go down. If this side went down altogether, the left side, the left 74 on the side of left, this would have what? Let's just play devil's advocate. Okay, so this goes down first. And it ejects this part of the deck off, this capping off, including part of this waterproofing, which acts as a membrane, a connecting membrane, if you will. It goes down there, and then the secondary part goes down here. Well, what are the odds when it goes down? When they go down separate from each other, playing devil's advocate, that they land lining up perfectly across the caps here, across this section here. No odds on that. So then this is probably a bounce. It broke and probably bounced. An elastic collision. Looks like a fracture right there also. Looks like a fracture there also. So when it goes down, it is ejected this direction towards us. This is before the main structure goes down. That this failure, this has to be included as part of a one-off, a one section going down together. Reacting together. See how it's all lined up. So this is very telling in the failure of this, and it aligns with the cars. So it aligns with the car behavior. There's a fracture there, thereabouts, and there's a fracture there, thereabouts. So it didn't make it past the pole, behind the pole, because you can see this presents like in line. It didn't make it behind the pole and then bounce off the ground and bounce up into the air over this column and land here. No, it was already fractured, as we saw with the previous imagery in the background here. And then we see it as it goes down, this lifts it up. This is it gets elevated, and a direction is formed on how it's elastically being ejected. And that's off towards us. So if I were to rotate the car area down first, would this come towards me, or would it eject, rotate, push off to the right? Well, whatever you come up with, it's to the right. Whatever you try to theoretically come up with, doesn't matter. It's still to the right. So you have to say, okay, what if I tilted the deck to the right over here first? Well, this fracture doesn't support that. This fracture says that that it doesn't support that. There's no break here if you start fracturing the deck in this direction. The break is in this direction. This is that butterfly fracture from here down. The fracture is not supported in there. Considering these are panels, I think is sort of craziness to think that the slab was a bunch of panels. They're all integral with the reinforcement until they break free. That is, for example, over there by the pool deck. Now the pool where there's a construction joint. And there is rebar inside there. This is the hollow core. This is the waterproofing, as you can see. And this material. I'm sorry. And so on the other side is painted. Painted. This is a mortar that you're looking at. This is the inside box. So where do you put that back? Where do you place that back into this system? You see the top of the walls? I'm trying to do that. It's all present. So how do you get this piece here accounted for? This section here. This appears to be present back here. So my Columbo movers account for this. One of them, rather. This looks like a lot of water, you know, your water blistering, etc. And there's your slide action. This was obviously not pushing when it went down, not pushing against here. So it rotated out, ejected to the right. It didn't push this box. This box looks pretty much in plane as it does the outside corner here. I guess we won't see that. As it does outside corner here, all the way down to the floor. And there's the trash bin. As you can see, the top of the trash bin has been dented. You see clearly these dents in this trash lid. Oh, wait a minute. There are no dents there. Okay, so during this ejection and going down, it cleared this elevation, this height. It was not going off, first rotating, not first rotating, because this was at floor level. This was at floor level, and this planter box was actually below this. So during this action, it was so fast, it had to lift it, eject it off over this box, clearing it like a hurdle out to this point here. You could count the tile back and figure it out. You know, it's about 1, 2, 3, 4, 5, about 7, 8 feet that it was the arc of this was able to rotate from the heads. Remember, this was up here at one time. I know it's hard to think of that, but so I'll bring it down here for your simplicity of it. Here's the plant. Here's this. This was back here, and it came up and over. It came up, ejected it over. Okay, and you can see the profile. So here is less. To here it might be 5 feet. From back there, it's about 7 feet. And you see the profile of it. From here to here is a little bit further out. So you can see the shape of it. You can start seeing the shape of this cap and profile its distance from here. And you start seeing, oh, okay. This had a bending action right about here, and that's where the ejection started. And it was abrupt, and it was fast. It was cute. It was fast. It ejected it off, and there's the profile of the ejection, if you will. And you're looking at it right here. Literally, you're looking at the profile of the ejection. And a lot of that's doing with the torque that's created by some of the engagement at the center here. And we're trying to hold on. But ultimately, this is the way it ejects this entire system. Do not underestimate the elastic connecting ability of this material along with the face of it also. Do not underestimate this waterproofing to have a bond strength. Finally, I think I'll end this video with looking back at the heads again. So you can see that I think there's one that popped maybe on this or not. But this is that steel. The same steel I addressed over here. The same type of steel. Goes across the head. It's the critical shear zone of these are very... Alright, I wish I had this other video queued up. This guy is... I won't give his qualifications. That sort of takes away from it. But he stated that some scientists need peer review. If it's not peer review, they're not accepting anything new, period. Until it gets peer reviewed, that means a bunch of people will totally agree with each other, like-minded, and then it's published as such, saying, oh, it was peer reviewed. It should say it was supported by, not peer reviewed, but more like supported by, stroked, etc. And then you shop the same, you're like, yo, hey, you took care of me on that peer review, basically. Here's my paper. Can you evaluate mine? They're like, yeah, I owe you. Yep, I owe you one, whatever it might be. So be careful of the people doing the peer review. If you get Josh stating that this building was a post-tension failure at the roof, which he did a video on 100% of that, and then he deleted it after getting many followers. He quickly would get peer review, let's say, And they go, yep, I agree. I see what you did there. Yeah, I can see where all those anchors happened that way. And he pointed out all these anchors that were on the roof and how they would be and et cetera and how they would fail. And this is why it collapsed from the roof. He did an in-depth video of that. Anybody can. This is not slander because it's the fact. And now, if somebody quickly peer-reviewed them going, yep, I see it, then everybody starts getting on the ghost wagon, believing the ghost. So it's not, peer review is nothing. All right. What to me is much more critical is winning over somebody's position that has the voice. For example, even Josh has a voice on this because his video's out there. I don't have a voice anymore. I'm shadow banned. So my voice is through other people having to win to see my content and go, bastard, I don't like him, but yeah, I can see his point. I'm okay with that. Call me a bastard, see the point, but dispute it also. See if you can debunk it or refine it. And that's what we want ultimately, the real truth of the stuff. If you look again at this reinforcement here, look at the reinforcement on this column. It mirrors the reinforcement on this column. It mirrors the reinforcement on this column. Okay, I sent this the NIST, and I talked to them about the whole thing would be about the reinforcement across the head is going to tell you how this deck failed. All of this shows the engagement was lost on the left side, that this side was overstressed for its capacity to hold. Right here, look at this reinforcement here. I'm going to screenshot it. For its capacity to hold, and it's literally lost its bond strength. So this capacity to hold, let me show you here. And let's on this one, here it is here, right? On this one, let's pick on just the rebar, this part. The reason why is because that's where the reinforcement, the concrete shows. This shows lack of any bond strength. So the deflection over the years. This shows that it ripped somewhat. And it's about the same here. It's about the same. And this is the rebar that they needed. I wrote NIST when this was still salvageable about this. And they just told me here, they sent me a link. Basically, here's a portal. Send it here instead of here where I was contacting them. And next thing I know, after doing that one saying this is destroying evidence, I get shit canned. All right, so again, here's the profile so hopefully, I know, and you can see that it's a lot of rust on here. This rust works, but it's okay. This is concrete was on there at one time. You see how it's white? All right. And here is a better bond, as you can see, the gradation of the white, and now the gradation of the white is even stronger. So this is our bond strength here, from here to here, where it was holding up. And keep in mind, this deck had some deflection in it, and I believe that when the engineer came out to inspect this, they didn't know what they were looking at. That on the opposite side and back here, that this deck was was deflecting, and this was sliding. There's some loss of grip force going on, and there's looks like a larger piece, a larger head nodule of it. And so same thing here again. 100% this side held on. This is not a 88% deal with me. This is 100% I know what I'm looking at. This held on, and this side gave free. 100% I stick with that. So anyone who want to debunk me on that, I'm at 100%. That gives you, I'm not saying, well, it appears or 100% the other side gave free. I'm looking at what the slide is actually. Now, why did it give free? Fracturing, movement, because this is a hell of a thing to slide this much rebar across. Many fractures. This is, if I'm right, we're looking at the 5/8 inch temperature steel, the top steel of this. Now that one I'm going to leave to, I can't see it, but I'm going to guess it's the temperature steel. This puts it into an upside down deck beam thing. I'm going to do a quick ending of the video with that. Hopefully I'll end it with that. I want this to be questioned, and I want you to think of this as number 5 steel. All right, that's 5/8. And at the bottom it said we'll have number 4. That's 1/2 inch steel here. So they created a upside down beam. This is stronger at the top than at the bottom. this, of course, will take the deflection, but to deflect, this number 5 is going to resist. It's going to be more rigid. It's not going to want to, it's going to intercept that deflection to some degree. The concrete that's above it is now covered by further concrete, the deck slab, the covering material, the one that the Tong Long Lee, whatever his name is, the one that came and put the slab on top. We now can't observe it. This deflection, as this is the covering of the number 5 rather. So this is, inch and a quarter, whatever it may, 3/4 of an inch cover, whatever it may be. It's holding the slab from deflecting in a strong back capacity. So you guys have to look up strong back to figure that out. I'm not going to go down there, but the engineers, I want you to think of this as a strong back, a number 5, as opposed to a number 4 there. So it is acting like a crane, strong back, and this is the lower part that's then can take deflection. So what happens when we see deflection? When we see the fractures underneath in the parking garage area, you've already bent your strong back, and you've also bent your number 4, but you've got some weird behaviors going on here. If you want to go dive down there and look at research of this, there's many studies that showed doing beams and putting the stronger steel at top, putting the lower steel at the bottom, and look at the fracture behaviors. But do not just look at it without the narrative. Don't think of the narrative. If it says you're looking at a shear fracture, please disregard that. Go at it with open virgin eyes and just look at the fractures as they develop, and you'll see that upon deflection, the first thing you get is a breakdown here upon your steel at the end. That's because it's now spalling it off. It's ejecting it off. And then you get the transfer, since that's no longer capable of transferring, holding the deflection is there. Then you get this transfer into the, I'm going to move that over, into the concrete now holding. And it's the first point of its holding is wherever you see the bottom crack, the initiating crack. And then the next point is right above it, because now it's reduced. The profile of the concrete's reduced. And the load is still being applied. And then now it's reduced again. And it just looks, we're told it's a shear crack like this. In reality, it's just the reduction in the load is still coming down, and the concrete is now saying, this is all that's left. Okay, you're still loading it? Okay, this is all that's left? All right, with that fracture, this being open now, fractured, it's a crack. It says this is all this is left. All this material is left. It says, okay, you're still loading it? And we got a crack here already? Okay, we'll bend here. Okay, you're still loading? Okay, now what's left, the concrete reduction, what's left, and the stop steel behavior, maybe we'll shift a little bit. Okay, you're still loading. Okay, here, 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 here. And then it's called a shear fracture. But in reality, it's the bottom steel first spalled and ejected this area here, and then the new behavior of this beam is now without this reinforcement playing along, and it's playing along to some degree, very, very minor degree. And then what's left is now this concrete behavior with whatever steel's left. If it's got shear links in it, it's going to be a different. If it's got stirrups in it, it's going to be a different failure than the one I just showed you. If it's just top steel and bottom steel, it'll sort of fracture like that. All right, you can question me on that. You can say, "Oh, I see what you did there," but I think it's more this. I'm totally open to that. I'm totally open to that. Ending the video with, you can clearly see that this left side gave free. 1, 2, and 3. No matter what NIST or anybody says, I'm 100% on this. This left side gave free. You can see where all of it is now, the tails of it are just about symmetrical. Here's this one at the top a slight bit. Remember, the car is probably holding it up. This one's a little higher. So this tells us what? There's probably another car under here that held the steel up higher. But nevertheless, this is the radius right here. This is where it was across there when it gave free. See that radius? Oops, here's the radius here, mirrored up. And the radius here is mirrored up here. There's no car here, so this goes down further down and presents itself at this point as it comes to rest. All right, hope this was helpful for you. Love you all, and I welcome Professor Don Lehman to step forward on this. I know it's contrary to your conclusive files, as I call them. If you're not up to date with my conclusive files and amygdala theory, it just states once we make a conclusive file, it's very hard to move from. And it's because it's protected by the amygdala. I believe the amygdala, this is all I really want to be known by, my amygdala theory. And no psychiatrist has been able to debunk me yet. They may call me crazy. No, I'm just teasing that part. No, they have not been able to debunk me yet, and I have put a bounty on this to debunk me on my amygdala theory, that I believe that it does not do retreat unless it's still fighting. So what you consider a retreat is really still a fight. So I leave you room to retreat and fight. But ultimately, for me to win over the souls of people watching this, sorry guys, I got to do this. So maybe this will help open the file up for people like Professor Lehman to join in and not hate me with how she might have a conclusive file that I attacked her. Well, I took her position as attacks also. And now I'm studying the olive branch. Hopefully she can do the same. So the amygdala theory, this is the amygdala theory. It only has 3 positions. So one, this is just data. So in this column is just data. All right, let's just do that. So these are just bullet points. This is just, okay, that's rebar, that's concrete, that's a column, this is a parking garage. That's what I just point out here. That's just looks like rebar engagement, concrete engagement, concrete engagement. Okay, got it. The columns are offset. These are not in line. Okay, got it. A trash can is not damaged. It was at one other place, just data. All right, so let's use this conclusive file with the rebar, how I'm at 100%. So this is the rebar. All right, we know what it is, so this would be rebar, everything I stated about there. Once we make this data, we then decide, can we make a conclusive file? It's kind of automatic. It's sort of like you seeing your boyfriend, girlfriend, significant other. You see them whispering on the phone. You see them doing texts late at night. You see them giggling at the phone. Not to you, mind you. All these things. And you're not really communicating. You're not really in a happy time in your relationship. And then they're kind of keeping it from you, and you're walking in. What do you start thinking? The person's setting up for a new relationship. They're moving on. And so that's a conclusive file. It's only a conclusive file. You also say, well, maybe it's something else. All right. But you're like, you know what? There is nothing else. No. This, and then you start supporting. So maybe it's something else. This means you have doubt, and you run the data again. And when you run the data again, you come back to the same answer and go, But your amygdala is protecting you as a human. I state it protects your conclusive file. Any conclusive file you have, 2 and 2 is 4. That's protected by the amygdala. You're triggered by it if somebody says it's 5. That's why we're triggered by people using different pronouns, because it attacks the people that say that that's not possible. We're only male and female. All right. So that's the trigger on that. Of course, it's possible if you have, well, I don't want to trigger anybody on that. I'm going to leave this alone. So we know that those are conclusive files, and it's accepted across the board that 2 and 2 is 4. Now, this would be accepted across the board. If my data is wrong, you need to correct me on it, such as that's not rebar you're looking at. That's a post-tension cable. I'm like, oh, shit, that might change it. Now it's snapped. But no. We see the length of it appears about the same. They're all seeing about the same length, so they sort of went across the heads with that same length. Remember, these heads are staggered, but they present as a significant amount over the head. This one only presents as one showing, whereas the other one it would ask, right? That one too. All right, so we have data, and then from this data, I make a conclusive file. I'm like, you know what? That's rebar. It all gets engaged from that side. That's my conclusive file. I kind of, because I know how the amygdala works, I don't want to dig my heels in too deep, so I say, I welcome you to debunk me. So I leave open that I can be wrong, although I say I'm 100% right on this. But I leave open that I'm not going to argue this 2 + 2, 4 position. I'm saying I'm 100% on this. And if you can say, yeah, your data is corrupt because this is a snake. I'm like, oh shit. I look at it, I'm like, oh, it's a snake. All right, my 100% is now out the window. It's a snake. So I rerun the data, and I'm like, wait a minute, it's a snake. It's not rebar. So it can't be what I just stated. So you first have to change someone's position, you can't tell them your conclusive file is wrong. You have to say, let's go over the data. Why do you have this position? And if I look at the data and it's defective data, such as this rebar, not snake, then we can discuss that, hey, you got to change something here. But you can't change somebody's position just by saying you're wrong. You have to state that, unless they don't want to play wrong, you can say you're wrong trolling them. But unless you can show, tell me your data where you come to that conclusive file. And if they just say, because, I hate Trump. Oh, okay, well then, all right, that's your data while you have an agenda. If you have an agenda, don't bother trying to communicate with someone with agendas. This is a waste. They're not going to open themselves up to data. They just have an agenda. Their agenda is what it is, and you're wasting your energy. So so agenda doesn't work. So data, this is conclusive file, right? These are conclusive files, CF, let's say. These are conclusive files. They're protected by the amygdala. The amygdala is out here. So any file that's over here is protected. Now, I give my protection numbers. 100%. My amygdala on this one's protecting this by 80%. This one's protected by 40%. And it's over here. So we can have multiple conclusive files. So I state multiple ways that this can get here. This in the background. And so conclusive file, conclusive file. Neither one is protected by the amygdala because they can move based on somebody joining in and playing along, and we'll nail this. I'd like you to see this as I end the video. Don't save. And escape. I'd like you to observe that. All right, so take care, guys. Love you, and that's a clap, right? That's a wrap. Think about all this stuff. This is a pretty deep video, all the bending. I have a lot more I could share, but you know what? I need traction from other people playing along. I need traction, otherwise I'm just wasting my life away on this. Love you, bye.